Beyond statistical correlation, using VMT energy ratios to reveal hidden dynamics in 16-year reversal of type 2 diabetes number 1280, VMT Sharp 654, March 23, 2025. Gerald C. Shu, EclaireMD Foundation. Category: Diabetes. Abstract. Traditional medical research rely on statistical tools, like linear correlation to study chronic diseases, but these methods fails to capture nonlinear dynamics, causality, and interactive effects critical for understanding disease progression and reversal. This 16-year case study detailed the author's type 2 diabetes, T2D, reversal, with estimated average glucose, EcG, dropping from 277.5 mg per deciliter in 2010 to 90.09 mg per deciliter in 2025, a 67.5% reduction. Statistical correlations showed strong associations, are above 92%, EcG and 7 health inputs, 2 biomarkers, except lipids, are as 70%, and 5 lifestyle factors, but they don't explain timing or mechanisms. Using the Viscoplastic Energy Model, VMT, the author calculate energy contribution ratios that reveal physiological burdens of each factor. This paper compares statistical correlation with VMT analysis and interpret results pathophysiologically, offering deeper understanding of T2D recovery. Introductions. Type 2 diabetes, T2D, is a complex metabolic disorder, driven by genetic, physiological, and lifestyle factors. Mainstream research use linear correlation to find relationships, but this can't uncover causality or nonlinear dynamics, key for managing chronic diseases. This study analyzed 16 years of the author's health data, from 2010 to 2025, focusing on T2D reversal through 3 biomarkers: body weight, BW, blood pressure, BP, and lipids, and 5 lifestyle factors: food, walking steps, sleep, water intake, and stress. Using statistical correlation and math physical VMT energy, he show how VMT energy ratios provide better interpretation of disease mechanisms, compared to traditional methods. Methods: data collection. Author collect daily health records from 2010, Y10, to 2025, Y25, aggregated into annualized data. Primary outcome was EcG, the strain, correlated with hemoglobin A1c, reflecting T2D severity. 8 influential inputs, stresses, tracked. 3 biomarkers, BW, BP, lipids. 5 lifestyle factors, food, quality, quantity, walking steps, sleep, water intake, stress. Normalization and statistical analysis. Inputs normalized to from 0 to 1 scale based on standards. BW, 170 pounds, BMI 25.0. Food portion, 680 grams per meal. Walking, 7,000 steps per day. Sleep, 7 hours per night. Water, 3,000 cc per day. Stress, subjective scale, lower less stress. BP, lipids, based on clinical thresholds, e.g., BP, 120,80 mm of mercury, lipids, lab standards. Since 2014, the author follows the following lucky 7 rules for his health. Maintenance and T2D reversal. 1. Eat under 700 per meal. 2. Keep carb sugar under 70 per meal. 3. Focus on 7 foods: vegetables, fruits, proteins, nuts, fish, whole grains, avoid fatty meats. 4. Walk 7,000 steps per day. 5. Drink 7 mugs water tea per day. 6. Sleep 7 hours per night. 7. Keep 70% of day stress-free. Brief description of VMT energy model. VMT model treat EcG as output strain and inputs as stressors. Area under stress strain curve represent energy contribution ratio, quantifying physiological burden on glucose regulation. This capture energy dynamics of T2D remission over time. Note for medical readers: understanding conjugate quantities in biomedical energy modeling. In physics, energy come from multiplying conjugate quantities, such as force and displacement. In biomedicine, we pair physiological stressor, e.g., food intake or carbs and sugar grams, biological response, e.g., weight or glucose levels. For example, in diabetes, food portion or carb sugar intake act like a load on glucose regulation, with body weight or EcG as the response. Variables is normalized first, then multiplied, and integrated over time to get energy like quantity, showing physiological burden. This math physical method revealed disease severity and intervention effectiveness better than correlations. Results: EcG reversal. EcG drop from 277.5 mg per deciliter, Y10, to 90.09 mg per deciliter, Y25, a 67.5% reduction, showing T2D reversal. This aligned with reductions in his 3 biomarkers: BW, 1.31 to 0.99, 76%, BP, 1.50 to 0.96, 64%, lipids, 1.80 to 0.50, 28%, and improvements in 5 lifestyle factors, food, 1.76 to 0.48, 27%, steps, 2.33 to 0.55, 24%, stress, 0.62 to 0.51, 83%, sleep, 1.07 to 0.49, 46%, water, 1.05 to 0.73, 70%. Percentages shown here are calculated by dividing the Y10 data by the Y25 data. Correlation coefficients with EAG. Biomarkers, BW, 98%, BP, 93%, lipids, 70%, lifestyle, food, 95%, steps, 76%, stress, 92%, sleep, 93%, water, 95%. All inputs except lipids, 70%, show high correlations, above 92%, but don't explain causality. VMT energy contribution ratios. Biomarkers, BW, 38.3%, BP, 38.0%, lipids, 23.7%, less accurate due to quarterly data. Lifestyle, food, 29.0%, steps, 23.3%, sleep, 18.2%, water, 18.0%, stress, 11.5%, low due to the author's stress-free lifestyle. VMT ratios reveal hierarchy of impact, capturing nonlinear dynamics that correlations miss. Total VMT energy, biomarkers, 25,224, average, 5,041, lifestyle, 26,447, average, 5,289, with 49% from biomarkers, 51% from lifestyle. Final VMT contribution ratios for the 8 combined factors. BW, 19.2%, BP, 19.0%, food, 14.5%, lipids, 11.9%, steps, 11.7%, sleep, 9.1%, water, 9.0%, stress, 5.8%. The cumulative VMT energy curves over the 16-year time zone for combined biomarkers, BM, and combined lifestyle factors, LS, are highly compatible, both reaching 100% by Y25. This highly compatible curve shapes and close alignment of data reflect parallel changes, driven by the progression and control of type 2 diabetes, T2D, showing that both biomarkers and lifestyles contribute almost equally and consistently to overall metabolic stress and recovery. Discussion. Statistical correlation, informative but shallow. High correlations suggest variable associations, but don't show causality or interactions. For example, stress, 92%, and sleep, 93%, correlate strongly with EAG, but VMT shows sleep, 18.2%, impact more than stress, 11.5%, likely due to hormonal regulation versus low stress lifestyle. VMT energy, deep but complex. These VMT ratios reveal how individual variables alleviate metabolic stress, providing a nuanced view of T2D, reversal that traditional statistical tools have failed to capture. Pathophysiological explanations of 3 biomarkers. BW, 38.3%, visceral fat increase insulin resistance. BW reduction lower insulin demand, improving EAG, 277.5 to 90.09 mg per deciliter. BP, 38.0%, hypertension impair insulin signaling. BP reduction enhance glucose delivery, notable in Y2014. Lipids, 23.7%, secondary role. 70% correlation and lowest VMT energy among biomarkers, reflecting metabolic health benefits, not direct glucose impact. Pathophysiological explanations of 5 lifestyle factors. Food, 29.0%, control on food portion and carb sugar amount reduces glycemic load, driving EAG drops, e.g., low carb diet in Y2014. Steps, 23.3%, daily walking, minimum 7,000 steps, improves glucose uptake, supporting metabolism. Sleep, 18.2%, and water intake, 18.0%, sleep regulate hormones. Water aid renal glucose clearance, both supportive. Stress, 11.5%, low impact due to the author's low stress life, but reduction limit cortisol excess, aiding EAG. VMT and NNM versus correlation. Correlation misses nonlinear, dynamic, and plastic, partially irreversible, effects, as well as multifaceted interdependencies and time-lagged responses. In contrast, the VMT model captures these complexities, providing a macro-level perspective on biomedical phenomena. On the other hand, The Neural Network Big Data AI Model, NNM, offers a micro-level perspective, focusing on outliers identification, and enabling detailed monitoring of disease progression. Conclusion: this 16-year study highlight correlations limits, and VMT's superiority in understanding T2D dynamics. VMT show BW, 38.3%, BP, 38.0%, and food, 29.0%, as key drivers. Lifestyle factors like sleep, water, and stress, though correlated, contribute less. In a combined biomarker and lifestyle VMT analysis, it showed the ranking of influence as BW, BP, food, lipids, steps, sleep, water, stress. Another key insight the author gained from this research is the importance of closely monitoring his pulse pressure. Elevated blood pressures, particularly the widening gap between systolic and diastolic pressure. Pulse pressure, combined with aging, increases his risk of cardiovascular disease, CVD, and chronic kidney disease, CKD. VMT offer deeper perspective on chronic conditions and scalable framework for predictive medicine. It should complement, if not replace, correlation in metabolic research.